I'm not interested in React. It's very hard to follow up with that show, but so you know. We have just a couple of announcements. Today we have recording for our event by Product Forge, and they have a hackathon happening soon. And Tabitha will tell us a bit about it.
It's actually a live stream, so if you want to tune in live, you can. And just so you guys know that we offer free live streaming for community meetups, mostly in Edinburgh, but we also do Glasgow. So if anyone runs a meetup and is interested in getting that live streamed or recorded, you can get in contact with me. I'll leave some flyers. And we also facilitate hackathons. Well, they're a little different than super geeky hackathons because we usually partner with a public sector organization to tackle some kind of social issues. So the one we have coming up is part of the Cancer Innovation Challenge, and the aim is to tackle cancer care within Scotland. So we're going to have not just digital technology people, but also people from the NHS, so on the clinician side of things, but also from the data scientist side of things. So it's next weekend, starting on the 15th, Thursday, running 24 hours a day until Sunday. And each team has to be made up of a diverse group of participants, and at the end we'll present their product prototype that's really tackling a specific issue that has like a real business case around it. So there's been some amazing projects that have come out of it, have even gone up to start their own little companies. So I highly suggest you check us out. I'll leave some flyers out there on the way out. You can ping me an email if you're interested. Thank you.
Jobs. So yeah, we normally do also if someone is looking for a job or someone wants to announce a job, but we'll have a break between the two talks, and if anyone wants to do an announcement, if you just come and tell us, and we can do that after the break. There is also next week, Sway, there is the Edinburgh JS meetup, and it fits nicely because with the Elm talk that we have today.
Yeah, so we are hosting a special edition of the Edinburgh Jazz Meetup next Tuesday, and then we invited the creator of Elm come over, and then he will do a talk, or actually more a workshop at Codebase. So if you want to sign up, and just search Edinburgh Jazz meetup.com, and then yeah, I think we got like maximum 90 people, and we only have 60 people sign up. So there's still plenty of spaces. Yeah. So yeah, that's it.
Also, you know, we do the project Code Your Future, the School for Refugees for Coding. We have in Tech Meetup next week, on Wednesday next week, we'll have a talk about Code Your Future, how it's been going so far in Glasgow and in London. The class that graduated, actually, the 4 graduates got jobs there, and we'll be talking about the project in details, what's been happening in it so far. And now, Deloitte, probably.
I don't know why he's so scared of the microphone.
Yeah, I know, we're not used to it. I was telling him I don't have plates at my place, and now like this is so fancy, so nice.
Okay, well, welcome everyone. I'm Vati Gunar. I work for Deloitte Show, and we will start by just showing you a video for 1 minute. Let me just switch off the lights quickly, if I can.
Welcome to the Deloitte Digital Factory, running for you in our studio.
We've had hundreds of ideas submitted to us by our customers. Mark is our product owner.
The business has voted, and now I can see the best ideas for development first. Right now we've got 5 apps in development, 4 in the pipeline, and 3 in prototype.
We started working on this prototype on Monday, and we'll be presenting it back to business on Friday. If they like it, we'll have a production ready in a few weeks.
We use an agile approach, so you can see the product sooner and catch any issues early. Dan's one of our solution architects.
We're in a discovery sprint for this app. We're going to be saving time by reusing some existing code. Plus, we're going to develop signature capture as a reusable component. Our Scrum Master is Flo.
We're just finishing our daily stand-up. We have 5 Scrum teams across the globe, with the ability to add more to meet demand. Mel is our dev lead.
We've been at the agency for 6 months now, so our velocity is consistently improving. Hi guys, how's it going in Hyderabad?
Hey Mel, we're looking forward to getting started on the build. I've already picked up a user story and we're getting clarifications from the BA and tracker.
Once app development is done, we move into final testing.
And because of the amount of automated testing we've developed since we started, we can now test faster than ever before.
Our merge and deploy team makes sure apps get to production safely without impacting our users. We're doing a major release every week now.
Here's your dedicated support team.
If any issues arise after go live, we'll make sure you get the support you need when you need it.
Finally, I lead the tech adoption team. My team excites and engages the users. We're not happy until all of our users are happy.
So, this is our digital factory. Are you ready to get started?
Well, I can assure you no animals are harmed in making the video, and there were no any paid actors who were paid. I'm very excited to host this meetup. I think this is, from a meetup point of view, going back to the community, this is the first thing we have done in Edinburgh. And to be honest, this video was made for a different purpose, and Deloitte Factory is a different thing. I won't really be talking about it. We're a big organization, the Deloitte Digital. Deloitte Digital is part of the Deloitte, which I think most of you would know is a very big management consulting firm and audit firm as well. So Deloitte Digital is a practice within technology which is rapidly growing and is the most profiting business in the firm at the moment worldwide. And we have these offices, we call them studios. And the experience that you might have got here, obviously you haven't seen a workplace where we actually work downstairs, and we have bean bags. It's a very casual and cool environment. So we work very differently from rest of the organization. Like a good example is normally in a consulting firm, we'll have these locked down laptops and stuff. Our laptops are open. You can listen to Spotify and download any tools, platforms, programs you want to. Anyways, I don't want to really talk too much about the firm. Just want to say that the Deloitte Digital Studio in Edinburgh was opened officially last year. And we are building a team, particularly our engineering capability. So I have some of you, I know, I've even interviewed some of you guys who are here. And we are trying, it's a bit challenging what profile we are looking for, because obviously at the end of the day, we don't have a product that we manage. We don't have a product that we provide application support for. We work with clients and we solve their problems. And there are some statements in this video that I think they should not be there, because that's not what we do. Just some, not many. So that's everything. I mean, obviously you guys have engaged with Matt, Zach, and Freddy, who are in the back. If you guys have any questions or you're interested to learn more about what we do, what sort of opportunities we have, please come and speak to us. We are hopefully hosting, if you guys don't know, we don't have a date yet, but there's a code bar. Tony's here from there. We'll be hosting a workshop, and hopefully we'll have one more NGO, Code Your Future, there as well. It's not planned, I mean, it is still in planning, but it'd be really good if the tech community can go back and contribute to the wider community as well. So thank you very much, and again, welcome. I'm really excited for the talk. Thank you, Matt, again for coming all the way from London to do the talk. So I think it goes back to you. Cheers.
Can you guys hear me? Mm-hmm. Yeah? Cool, mic's working. I was just going to add to the video that I know all those people, and they're mostly engineers, so that's like an Oscar-worthy performance. Right, so I'm going to talk to you about React and sort of my experience using TypeScript with React. So let's kick off. Right, so first off, who am I and why am I talking to you? So as what G mentioned, I'm from the London office. I came up this morning on the train, beautiful day for it. I've been using React now for about 3 years. I've also been with Deloitte for about 3 years, so pretty much my whole time here I've been a React developer. And I actually used to be a back-end developer, so my background is actually in .NET. So you might see why my interest could be piqued with using types in JavaScript. And if you're confused by my accent, I'm American. That throws some people off. Last thing is I don't really use Twitter, so I know that was put into the meetup, but if you want to get in touch with me, GitHub's probably the better way of doing it. So, question time. Actually, first question from talking to people, who actually uses React here? Okay, good, that's better. I met a few people that actually didn't use React, and I was like, this is a React meetup, so cool. Next question, who's heard of TypeScript? Good, all right, a lot of people. Who's using TypeScript already? Like, as in a project or in personal projects? Okay, so that dropped down significantly. Who wants to use TypeScript? Okay, that's interesting. So half of you have actually heard of TypeScript and don't want to use it? Interesting. So who's not interested in TypeScript? That was about half of you. And then, who's just here for the free food? That'd be the same thing. So, cool, so that's out of the way. So, what is TypeScript? The definition, if you go to typescriptlang.org, this is the official site from Microsoft. TypeScript is a Microsoft, it's not a product, it's not a language, but it's backed by Microsoft. It says TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. So what we need to pick out from that is that it's not another language, it's a superset of JavaScript, and it compiles to JavaScript. So JavaScript is TypeScript, and I'll explain that in more detail. So what is TypeScript trying to resolve? JavaScript is weak, and by that I mean it's weakly typed. And if anyone's a Seinfeld fan, which I know in the UK is a really tough ask, it's a really fun gif. But JavaScript is weakly typed, and so what that means is, I'm just going to demonstrate it. So I'm going to talk about type safety. Can you guys see that in the back? Yeah, good. Cool. So we're just going to go through some lines of code and just see what you can do in JavaScript that you probably couldn't do in other languages. So we can declare a variable, we'll call it 1. We can set 1 to the number 1, very simple. The next thing we can do, which is something you can't do in a lot of other languages, is immediately set that variable to a string called 1. And you can go down the line, you can make it whatever you want. You can make it an array, that's fine, that's allowed. You can make it a function that returns an array, why not? So sometimes that has benefits and sometimes it doesn't. So when you want to call a function and you send it the variable 1, how do you know what it's going to do? Is that allowed? Is it fine? You usually you don't find out until you run it. So JavaScript doesn't do type checking at compile time, it does it at runtime. So that's why we're always sort of looking in our console log for red messages to say, can't call this function of undefined and all that. So that's kind of what we're dealing with. So I was going to go through a little exercise. So this is just a function. I assume everyone's familiar with ES6 syntax. That's just a function, takes in a parameter a, increments it by 1. So what does this do? Increment the number 1. 2. Yes. Who knows what this does?
2.
Yeah, exactly. We know what he knows. That worked perfectly. It's actually 11. It's a string. So think about it. String 1 plus 1 if you, 11. So, it's kind of funny, but what if you're actually using it? Like, what if you're using a function that returns a value and then you put it into moment? So we know this returns 2. Moment add 2 days. That's going to return, the 9th of July, June. Again, American days. But then what happens here? So we've got increment string 1, which is wrong to begin with. That returns a string of 11. How are we going to add a string of 11 days to today? Like, fortunately, the smart people at the moment just handle this, so you don't even get an error. But this is just kind of the weird stuff that you can end up with JavaScript the way it is. So what if we could catch these errors at compile time? What would that look like? So we use TypeScript. Basically, like I said, it's a superset of JavaScript. So the syntax is slightly different. I'll just point to these. So we've still got our function declaration, and now we say a is a number. It can only be a number, can't be anything else. And this here, colon, is our return type, so it returns a number. And now we just have a plus 1 as we would otherwise have. So now when we say increment 1, nothing happens when we compile. If we try to say increment string 1, we get this little message here, and it says argument of type string 1 is now assignable to parameter type 1 of number. So that's what we want. Like, we want to catch this when we write a code. We want to catch this before we, run Webpack or deploy it or whatever. And if you use TypeScript, you'll get really familiar with these TypeScript messages. That's a simple one. One of my annoyances, which I'll get into later, is the messages. So easy, right? I think that's a very, very basic example. But let's talk about arrays and objects. That's a little bit less straightforward. So this is how you would declare an array in TypeScript. So same sort of const my array. You give it a type number, and then you say brackets, and then you can just set it to 1, 2, 3. There's also different syntaxes you can use. So I would suggest just pick one that you like, that makes sense to you and your team, and just stick with that, and just be consistent. But these two are exactly the same. So you can say type and then bracket, or square bracket, or you can say array and then give it a generic type of the type that you want it to be. So how do you do an object? Objects is probably what we deal more with in React, and these basically require an interface. So you need to tell it every property that's going to be in an object. But you can actually make these optional. So you see A has to be a number, B is a number, C question mark. That's how you say something's optional. So as you can see in my assignment, const my object of numbers, colon, the type is my interface, just A and B. I haven't given a C because I don't have to. C might not be there yet, or adding it later, or sometimes you just don't need it. And what that'll do is, if you try to say then, say you got a function that takes in my object, and you try to say C.substring, immediately TypeScript's going to say, I don't know if C's there or not. So actually, you can't run C.substring unless you have an if statement around it. And it just will not compile until you do that. And that might make you think about, maybe C should be required. Maybe C should always be there. Maybe it should be initialized. That's one thing I like about TypeScript. It kind of makes you think a bit more about your code. And then the final one is an array of objects. So kind of like the array assignment, but you just give it your type and then square brackets. And then you can give it your array of objects. Cool. So that's all too much for you. Too many rules, too many errors. You can actually, there's a way out of this. It's one of my favorite movies, favorite gifts. You can just say any. So actually, if you just want to try this out, you want to try it on your project, you have 200 TypeScript errors, you just kind of want to bail out of this and just try a little bit at a time, you can just say any. So in here, we're actually saying this is an array, but what's in that array can be anything. So I've got a number, I've got a string, I've got a goat. And then same with an object. I've just said this could be anything. So I could actually say just one, I could give it an array, give it an object, just give it anything really. So that's kind of a helpful tip, but I wouldn't recommend using it all the time. Just sort of when you're getting started. And yeah. Cool. So let's just sort of recap on all that. So why TypeScript? One of the reasons is because JavaScript is TypeScript. You can, based on your configuration, so there's a bit of an asterisk to this, based on your configuration, you can just rename your file extension from JS to TS, and it will compile, and it's fine. I wouldn't recommend doing that, but I'll get into that later. So the benefits are you can catch your errors earlier, so as you're typing or you're refactoring, you just immediately get a message saying, actually you can't do that because this other file that you wrote 5 months ago depends on it, and you find out why you're writing your code is pretty good. So yeah, better refactoring for the same reason. More readable code, that's kind of subjective, but I actually now, I've only been using it for 3 months, but I actually now read code, and if it doesn't have a return type, I actually get kind of annoyed with my fellow developers if they don't do that, because it actually then requires me to read the entire function. If it's a big function, it has a couple of return statements, and it's kind of annoying. If I could just have a return, returns a string, returns a number, it's more readable. And then documentation. If anyone uses JS doc, you don't need to do that anymore because you know what all your parameters are, you know what it returns. and better IDE support. So it depends on the IDE, of course, but a lot of them, I use VS Code on my Mac, I've used WebStorm on PC, I've used Atom, I've used Sublime News, but they all just work better. So as you're writing your code, you get IntelliSense. Like I call it IntelliSense, I know this is a Microsoft thing, but that's what we had in .NET. But it just tells you like what your options are, what you need to do. It just really kind of makes writing code a lot easier. So maybe why you wouldn't want to use TypeScript is because a slight learning curve. I don't think it's prohibitive, but there's a little bit of one, and mostly you're just going to get errors that need to be resolved, and it's just kind of annoying. Linters are kind of a pain because, so linters, well, ESLint specifically compiles to ES-tree's abstract syntax tree, and TypeScript can't do that. However, there is a GitHub project that's working on fixing that, so that's kind of helpful. But linter can kind of be a pain. And there's TSLint, but it's not very mature, so it doesn't have very many rules, so you can kind of use both. Error messages can be confusing. Hopefully I'll show you some of that when I'm writing some code. And then if you're just writing a quick prototype, then I wouldn't bother with it. Like, it's a prototype anyway. But if you're working on production code, I think TypeScript is ready. I think it's mature. I know some of you have used it in version 1 and didn't have very much success, but I think it's come a long way, and I think it's really worth trying again if you've already tried it. So, TypeScript with React. I figured this would just be better to show you some code. So my idea is I'm going to take a boilerplate that I tend to use when I'm starting up just a project, and I'm just going to rename a few files, show you just sort of how I'd start making it a TypeScript project. So actually, first thing I want to show you is the file changes that I made. So what I did was I cloned this repo a couple days ago when I was making this presentation, and I made a couple changes to it. But I can't zoom in on this, so I've got some screenshots that hopefully I can show you real quick. The first thing I want to show you is my package JSON, which doesn't really open. That one. Right. So I actually added 3 things here. I added TypeScript. Ignore Redux Slunk, it just added a comma. I added TS loader, which is for Webpack. So if you use Webpack, you know you need to use loaders. Fair enough. And then I added something called @types/React. One of the other things with TypeScript is if you want to say import package from wherever it is in your node modules, you do require it to have a type definition file, and that's just basically a file that lists all of the possible interfaces, every method signature, all that, which you can auto-generate, but you need to have that, and you can get around it by just using require, so that's an option. But actually support for this in the community is really, really good, so it's not really a problem. You just need to remember to say import @types/whatever you're trying to use. Hopefully that makes sense. So that's a package JSON. I added 3 things. The next thing I did was I went to Webpack. I see what it did. And so I added my loader. So I'm just looking for all the TS and TSX files. I'm using, these go in reverse order, TypeScript loader, and then Babel loader. So what I'm doing is targeting, actually I'll show you the next slide first. And then resolve, you need to tell resolve, or tell Webpack that it needs to resolve those extensions, so .ts and .tsx, as well as JS, and whatever else you're using. And strangely, an empty string can be used by Webpack 1. Right. So this is probably this is where you need to make decisions. So this is the tsconfig file. And this just sort of tells the TypeScript compiler what you want it to do. I'm just going to pick out a couple of these and talk about them. So this first one here is allow.js, and what that means is say you're importing a component that is in JavaScript, and you're importing it into a file that is in TypeScript. By default, the compiler will not let you do that, but I'd say most of the time you actually do want that to just work. So that allow.js just allows you to mix TypeScript and JavaScript. I'd keep that on. No implicit any. That is, if I was just starting a project, I would turn that off. But if I got a project running, I would turn it on. And what it means is if you've got a function, so like we had our increment function, it forces you to put a type on it. It won't just let you say A without a type. Module and target. So module ES6 just says we're using ES6 modules, which I recommend doing, of course. And then target ES6. And the reason we do that is the default option is ES5. So TypeScript compiles by default to ES5, which is okay. But if you want to use stuff like spread operators and all this, like the fun stuff that's in ES6, you might as well just have it target ES6. The syntax for TypeScript is ES6 anyway, so really all it's kind of doing is just removing your types and then just handing that over to Babel, and then letting Babel do what it would normally do. And if you already have an existing project, that's probably what you have anyway, so it's just worth targeting ES6. And then JSX preserve, kind of the same thing, just don't touch JSX. Cool, so we're all set up. And now, we're going to go into VS Code. And, right, so get status, make sure, yeah, so just my one commit that I showed you. And if I say npm start, and go to Chrome, and go to localhost 3001. Live code every time. Unexpected token. Ah, did you run yarn? Yarn install Redux. Yarn add Redux. Errors. Sorry, where did Chrome go? Right. Made it. So, this is just a simple boilerplate. This is just one that I tend to use. All it does is show you basically how Redux can work. All it does is increment this number up and down. That's all it does. So what we're going to do is we are going to open this file called counter. People, you're looking at the back screen anyway, so you can see. Good. Everyone get to see? Don't need to zoom in? Right. So this is just a JS file. It's just returns some JSX. It's got a counter. It's got 2 buttons and a label. So the first thing that I'm going to do with this is rename it. And I'm going to change the file extension from JS to TSX. Next thing I'm going to do is actually rerun Webpack, because Webpack doesn't seem to like it when I change file names. And if I refresh this, it should just load. I practiced this many times now. Right, perfect. So this is a good thing actually. So you're going to get a lot of TypeScript errors like I showed you. So prop doesn't exist, prop types doesn't exist, component requires 2 type arguments. And our IDs pick this up. So this is what I was saying why I needed to add the @types react. So it kind of knows like what component is, and the fact that it requires now 2 types. So the 2 types it requires are our state. Actually, can I hover over that? Yeah, so it tells you that it needs 2 types, P and S. P is props, S is state. So we're just going to start by saying any. The next thing is props implicitly has an any type. That was the TS config that I was explaining to you that I would turn off when you're starting and turn on when you're running a project. But all it means is we just can't have props any. If we were to have that setting set to false, then this would be perfectly fine. But we'll just set it to any for now and get that done. So the rest of the file looks okay. No errors, except for the fact that it's telling me that prop types does not exist. So I'm guessing that what they've done is when they created the index.dts file, the @type/react file, they intentionally left out prop types. Like, we all know prop types exist on Counter, but it's not going to compile to that because it's not in the index.dts file. And I'm guessing that that is because they want you to use an interface. So what we're going to do is comment this out. It's still useful to us. I'm just going to put it at the top of the file. And I'm just going to leave it there for now. And I'll come back to it. So I'm going to save that. Hopefully now, Webpack is built. No errors. Refresh. Cool. So now we actually have a working boilerplate using TypeScript, technically. Not that hard. So next thing we do is we're going to be a bit more serious about this. We're not going to use any. Any's not a really good idea. So what I'm going to do is declare an interface. I'm going to call it, the syntax is interface and then sort of just the name of your interface. And then I always want to do equals, but it's not equals, it's just brackets. And then on here, you're going to define what your props are. What props does this component expect? Since we already have prop types up there, we know it's counter and actions. Counter is a number and actions is an object. So we're just going to say counter is a number, semicolon. And we're going to say actions. What I would want to do is just say actions object. But in TypeScript, you can't just say an empty object. Which I kind of find annoying, and I hope that they add to it. Because if I want to say it's an object, I actually have to say, you know, I've got A, and I've got B, and you know, whatever else is on it. So what I tend to do just to get around objects when I'm just sort of refactoring and changing stuff around and I come back to it is just, again, use any. Now I'm going to use my props here, and I'm going to use state as well. The convention I tend to use is just to put I in front of sort of the name of things, and that just tells me it's an interface. And then state is just going to be empty. So now we have, again, a happy file, hit refresh, loads, no errors. Cool. So I think so far it's been a fair bit of work, but not a huge benefit to us. So I think the benefit with React in particular comes when you then try to use this from another TypeScript file. And actually what I'm going to do is I'm going to be a bit more serious about this and just see how automatically I have two errors there that say increment and decrement don't exist. So I'm just going to say that my actions do have increment. And I don't think I explained this before, but that's how you tell TypeScript that your type is a function. So you give it a function, any parameters it takes in, and the return type. Semicolon. Always want to do comma. And same with decrement. It's just a function, doesn't do anything, but it executes. Cool. So the next thing I'm going to do is I'm going to go into this foo view, which I have home, foo. All it says is you're visiting the foo view. And no, that's the footer. Foo view. Got your footer. And I'm going to do the same thing. Just going to rename it TSX. So now the IDE knows that this is TypeScript, and the compiler knows this is TypeScript. But again, Webpack doesn't like file name changes. So let's import our counter. And we're going to just return counter. Simple enough. except doesn't like it. If this was JS, perfectly fine. I could hit save, Webpack would compile, I'd load the page, and it would say, I don't have props action, like what I can't render. But instead, we get this error message. And these are kind of the error messages that you get with TypeScript. They're really, really long and just full of things that you've never even heard of, like intrinsic attributes and intrinsic class attributes and React. I don't know what that is. Trick is, just go to the last thing that's complaining about. Property counter is missing on type object. So let's add counter. So counter, so this is sort of the IntelliSense that I get now, which you wouldn't get if you're using JSX. So we know it takes in actions. We all know, children, key, and ref, those are just reacting. But we now have action and counter. So we just add them in. And here it tells me counter is a number. So sometimes they're like counter 5 string, what did I set it to? You just set it to a number, just do what it tells you. So counter equals 5. Equals 5. Equals 5. And then we're going to add actions. And we know that actions is an object. And it takes in increment, which if I would have slowed down, you could have seen the type. But we're just going to say alert increment. And we're going to say decrement. It's just an object. Turns alert decrement. Cool. So now I hit save and it compiles. If I refresh the page. Okay, so we've got a counter, it's set to 5 now. Good. If I hit plus, we get an increment. And if I hit minus, we get a decrement. So in not a lot of time, we've converted a project to Webpack. We've converted 2 of those components into TypeScript. And I mean, this is a really basic example, but hopefully you can kind of see like where the value is coming from with this. Yeah, so that's all the live coding I had. I just wanted to keep it really simple, but there's a lot more that you can get involved with in this. So let's go back to my presentation. And how much time do I have? So the problem is, I wrote this presentation with something called Spectacle. Does anyone use Spectacle for presentations? Yeah, too bad. Basically, you write a presentation in React, which as a React developer kind of makes it a little easier. I'm just going to try to show it to you real quick. But yeah, so like, you just give it slides and a heading and next thing to do. But the problem was I stopped running it. Hey, there we go. Okay. So anyway, thank you. I guess that's probably good on time. So if there's any questions? Yeah.
Just one of the issues we had when we initially tried to use TypeScript was just around testing, like looking at Mocha and stuff like that. Have you done much with?
Our question was just around testing and how TypeScript plays with
with Mocha and yeah. So I've actually used both. On my current project where we're using TypeScript, we did make the decision to keep testing as JavaScript. So we run Mocha with just JavaScript. I've played with using TypeScript in my personal projects, and like anything, with setting up a new test framework, there's a little bit of configuration. I found it a bit annoying and I gave up on it. So my advice for now is to just use JavaScript. Like, there's actually no need to change anything. So you can run your TypeScript files, pretty sure. Did you have that problem? We can talk about it. But anyway, we're just using JavaScript. But you can, actually in sort of my Googling for issues, I found that most people are using TypeScript for their tests, but you don't have to do it that way. So
you let TypeScript do its thing.
yeah, pretty much.
So,
Okay.
that's fine, I can shut. So, TypeScript is trying to solve the same problem which also Flow is trying to solve. Why do you think TypeScript is a better alternative? Or do you think it is a better alternative?
I'm not a good person to ask because I haven't used Flow.
Okay, fair enough.
So, I don't know. Sorry.
Fine, no worries.
Anyone else? One in the back.
Aside from developer experience, have you found, once you've shipped code that you've written with TypeScript, have you found that result? Have you had runtime errors, weird bugs, stuff you wouldn't expect with JavaScript? Has it been noticeably better to use TypeScript?
Yeah. We don't get compilation errors. We're actually working with another team right now, and that has its own issues. But if you're working with another team, they might do things in a slightly different way. Take timestamps, for example, a Unix timestamp. They set it to a string, we set it to a number, and we're working on a common repository. Not a common repository, but a common components repository that we both import. And that has actually, we've caught those kind of errors quicker because of using TypeScript. I think with most anything, new, there's a learning curve, and then you get used to it, and now, I'm actually a really big fan of it, so I'm talking about it, and I think it's really, I think it's a small investment now to get it up and running. I think it pays a lot of dividends. All right. Or do you have a follow-up?
Actually,
I'm sorry.
I suppose as an extension then, have you found the same value in testing? Have you felt like you've had to test less because you have types? Or have you felt like you've had to test the same thing because you were testing the same module?
I guess there's certain things. So it depends on what you're testing. If you're testing that my timestamp is a number or is a string, then yeah, there's less value in testing that sort of thing. If you're testing that I call Mocha with a specific string, then I guess you'd still find benefit writing a unit test with that. Cool. Yes, that's me. One more. Oh,
do you feel that now that do you feel that now that you're using TypeScript, that you're now writing less defensive code now, which is actually hindering you slightly? Because now your whole department now relies on using TypeScript. So if someone else was using your code, such as third parties, and importing your code in, you're actually relying on that TypeScript is checking your work for you. So they would need to use TypeScript. They can't just simply import your JavaScript, the compiled code. You see what I mean?
They can.
Yeah. But because you haven't put defensive code in to check for your variables and check that this is an array, that this is defined, because you're relying on TypeScript to check this.
If I have a library that I'm using TypeScript in, and someone wants to use it, they don't need to use TypeScript. Is your question less around that?
Less around that.
I think what he's saying.
Common repository, maybe?
Is that if you were writing the library, you're writing without TypeScript.
Yeah.
And somebody's passing in an object in plain vanilla JavaScript, you would be a bit more defensive about that. But with TypeScript, you don't worry about it. Was that
yeah, that's exactly it.
Okay. And would an example of that, could I even say taking in data from an array, from a service or something? So if I'm taking in variable, object, whatever from somebody else,
it's the other way.
So
you've created a library, or you contribute to an open source project that you wish other people to use. Because you're relying on TypeScript and you're not writing defensive code, is that hindering you contributing to open source projects or even giving your code to other people to use?
So yeah, normally if you have a normal JavaScript library, whatever input you're getting, you have some if else's in the beginning to make sure you're getting the right things. But if you're doing it in TypeScript, you just rely on TypeScript doing that for you.
But I'm guessing
if someone is consuming it.
If I'm creating something for someone to consume, with TypeScript, I'd have more certainty about what is going out. Like, it would be tough for me to like.
I think what they're getting to is the fact that you've written a library using TypeScript, so you're relying on TypeScript to catch your types and not actually having to write the defensive code to do that. Somebody else then uses the sort of compiled JavaScript version of that, and they can pass whatever they want in there because there's nothing to catch it anymore.
But TypeScript doesn't.
Because they're not using TypeScript.
Right.
If they're just using the products of it and not the TypeScript, please explain. Am I?
Yeah, we're getting
Yes.
Can
I ask it slightly different? Can I ask it a slightly different?
Sure, yeah.
What kind of JavaScript have defensive codes in it?
Yeah, that's the question.
There's
So when the JavaScript gets compiled?
So when TypeScript compiles to JavaScript, does it add in the defensive code?
No, it doesn't. So I guess that's something you need to watch out for.
I mean, my argument back to that though would be, you say that this function, your initial function, you passed in a number and added it, and then you passed in a string and 11. You explain in your library that I require an integer to be passed in as your contract. I mean, obviously JavaScript there isn't a contract.
Yeah.
Beyond that, yeah, that would be a problem.
Okay, so yeah, in that example, you would just get 11. Like there would be no defensive, like there would be no type check. Like you wouldn't. So I suppose if you're running a library and you do have people using it that are relying on defensive programming, then you still need to do that. But I would probably, if possible, try to encourage people to use TypeScript that are using your library. But I know at the moment that's kind of a niche.
Yeah.
But,
C-sharp.
Cool.
In a bigger project, does this add to the, like if you have a watch that compiles and now we added another thing, because even with just Babel and stuff, when the project gets bigger, you have a waiting time. Does TypeScript add significantly to a waiting time?
So actually, I probably should have put that in my cons. In this really simple example, like there's hardly any waiting time. So on my current project, we're actually using Windows, and that does add a significant amount of time. I'd say it probably adds 45 seconds to the build, which takes 5 minutes anyway. But on a Mac, it's maybe going to add 5 seconds. Like it's actually really quick. So it just sort of depends on how fast it's using.
Is that the build on a CI or it's just like
that's just
watch?
on that machine versus a client PC. Once you put it into Jenkins, it's super quick. So it adds a little bit of time because it's just like in Webpack, for example, it's yet another step at the end. So I mean, it's like adding anything else. It's going to take a little bit of extra time, but I don't think it's prohibitive. Back there.
Coming from .NET, how have you found the actual type system, the underlying type system in TypeScript compared to something like .NET where you have type inference and things like that? Have you found it easier or harder?
Well, I think at the end of the day, it's still JavaScript, so I can still opt out of types in TypeScript.
Everything is optional.
Whereas in .NET, types are, I guess I can use Java these days, but like there is some inferred typing, I guess, in .NET. I haven't used it in many years now, so that knowledge is kind of gone. But I think the main thing that kind of stands out is that you can opt out of a lot of things with TypeScript if you're using it. But then there's no point using it if you're opting out of everything. So either don't use it or use it.
How close does TypeScript follow the ES6 and ES7 specs?
Very closely. I'm not going to say there's no difference because I don't know, but it's hard to tell any difference. The main thing is just the extra sort of superset of syntax that you get. So just saying this is a type and this returns a type. Other than that, it seems very, very close to ESCs.
What did you use to make your website?
I swear, I get asked that so many times. Just to get it on record, I'll just show you real quick. If you...
Because I like the wee Pac-Man at the bottom.
Alright, so this is easy to Google. GitHub, Apple TV screensaver. And go to here. It's called Aerial TV, Apple screensaver, Apple TV screensaver. And you just basically download it, install it, use it. You get new screensaver updates like every week, so every now and then you'll get like, you know, new San Francisco thing, new Dubai thing, new Hawaii thing. Anyway.
But what was like your actual like presentation?
Or the spectacle.
Yeah.
I mean that's cool too.
So that is my formidable labs. So again, GitHub, Formidable Labs, Spectacle, and again, with this one, you want to go to the boilerplate, clone that, and then you start editing it. You can put in like color palettes. I use the digital green and black and all that, and then you just sort of have, this is the boilerplate, what it looks like. Yeah, showing off the presentation mode, which I didn't use. But I just want to scroll down to show you the documentation is pretty good. So you just sort of give it attributes like you would with anything in React. And there's sort of like base tags, which everything takes in. So you, like any tag, you can put the text color, margin padding, whatever you want. But it's really good. I've used it on like 5 presentations now. I couldn't go back to something like PowerPoint. Mostly for the fact that I'm like really OCD, so like if something's like 1 pixel off in a heading in between slides, it just drives me nuts. So this is great for people like me. Yeah, definitely recommend it.
That's great. Thanks, Matt.
Hello. Okay. We'll have a quick break. I think just a quick toilet break, beer break. We'll be back with James. We'll talk about React and Elm. That's it. If anyone has any announcements, come to look for us. We can have a little announcement in between the talks, jobs, opportunities, whatever. Come speak to us. Okay.
Hey.
if anyone has again announcements, just come up front. We can have quick announcements. We have one here.
Hey everyone, we are hiring instructors at Code Clan, which is a digital skills academy just down there at Codebase. So if you fancy a change from regular development, come see me or Tony at the back there, glasses and beers, or go to the website. We are hiring for instructors. Thanks.
That's great. And we at Code Your Future are always looking for volunteer mentors. So I think Muzaffar is going to talk about what we're doing on Saturday. Let's see if we can get some help.
So this Saturday is a good way to get involved. We have people just started doing JavaScript a couple of weeks ago. We started with TDD as early as possible. We have an exercise to do pair programming, one mentor with one student. We have 13 students. We want as many people, and it's a way you can just be involved one day, even just the beginning of it, not the whole day. It's more for them to see, like, to learn how to think in coding and so on. And it's a nice exercise for people who are teaching and people who are learning. So if anyone wants to get involved in this Saturday, just let us know, me or Will.
I will have James. Get off.
Is this on? Everyone can hear me? Good. So yeah, hi, my name is James. I work at FanDuel as a software engineer. One of the things that I'm sort of keen on as an engineer, I've used React for like a few years probably, is evaluating like React and why it's really, really cool and why I love it so much. So this is sort of a presentation of the journey of my findings and hopefully ending in a potential result that you guys might need as well. So I want to go through it. This is Google Slides, so it looks a bit weird and I'm a bit OCD, but like slides are everywhere, formatting's not correct, so you have to forgive me for that. So this is probably the best tweet I've seen about like summarising why React is good, or like basically just highlighting it. Like literally, it's like it was pioneering when it came out. Like I, for one, I'm not sure like how many of you guys have used it, or you used it like you're experiencing it, but for me when I first looked at it I was like, what the hell is this? Like JSX, like I want my DOM back, where is it, type of thing. But slowly and slowly, like it gave me experience in different programming paradigms, like more so like functional programming, and I could really reap the benefits of it. It's like a declarative view interface and it's really, really cool. So what I'm going to do is sort of talk you through what I've learned and I think why React is so, so good and what we've learned from it as a, there we go, what we learned from React. So functional programming works insanely well for building web applications, purely because your UI has a lot of state involvement. You've got a lot of user events doing various things, changing lots of states. Basically, all those are projections of different views, basically, and those projections should be based on state. So you pass in your projection is given this state, I want this view out, and it's completely deterministic, and that's what's really, really cool. It's a very declarative view model. Immutability works awesomely for like diffing the component tree. So, for example, if you guys have like ever looked at like advanced like performance in React, you might be aware of like should component update and the way that you can actually like stop React like rendering out subtrees if the props haven't changed. So that's really, really cool, and that's part of I guess that is owed to functional programming and immutability, and the fact that you can do object-based reference equality as well, rather than like deep equaling an object or a prop. Enhancing components through function composition as well, so like the idea of like high order functions and function composition generally. So rather than using like linear inheritance, so if you've, I guess, everyone's used potentially like React classes, like ES6 classes, where you maybe export a React component, but you extend from like React class, or however it is, I haven't used them in a while. Function composition kind of is the more functional approach to that, so your component is just a composition of many different components in the same way, so that's cool. And stateless components as well, so basically a component should, or you should strive for it to be a stateless component, so a pure function. So it's really easy to test. So given these props, I expect this result, and that's a predictable completely deterministic methodology and idea, basically, that we've got from project program. The DOM becomes an implementation detail, not a means of interface. So this is one of the things personally I found really difficult when I first started off. It's like, I want to mutate the DOM, or I want to do document or get element by ID, or whatever, however I want to do it. I want to interrogate the DOM. No, you shouldn't be doing that. Like, the DOM is, or the browser is like just a target for React rendering. I won't go into too much detail now, but like React 5, which is like the new version of React, takes that principle and allows you to create your own renderers for different like runtime targets, so like WebGL and like virtual reality and things like that. So it's a declarative interface, one interface, multiple compile targets or multiple like runtime targets. This is really cool as well. So declarative synthetics events interface. So the amount of times, I guess traditionally everyone's done document.getElement by ID, add event listener. So you bind event listeners to nodes, DOM nodes directly. When I first came across this, I was like, well, this is like an inline event listener, like on click, for example. Like, why is that a good thing? But actually, it's entire like encapsulation of concerns in a particular component, which is really, really cool. And efficient DOM updates through virtual DOM diffing applies batched updates. So React, you just tell it, I want to re-render this view, and that's just a side effect. That's an effect of setting state, potentially, or re-rendering the component tree, and React just efficiently applies that to the DOM, like flushes it to the DOM very performantly, so you don't have to worry about that. So React in itself is really cool, but literally all it should be really used for is like a views layer. Now I know that's kind of a contentious like definition of what React is, but ultimately if you want to scale and create an actual like application that can scale well, then you don't want to be using React as like your state management or side effects encapsulation. So as I said here, you need to be able to interact with the outside world like somehow, right? So if it's all very well like clicking away like a button and it highlights some text if it's on a form, for example, you haven't filled in, that's all very well, but like you will need to probably actually like interact with the outside world. So maybe do like an HTTP request, or like WebSocket, or publish or subscribe to something outside of React, outside of the global world. And as I touched upon before, like state management, that's really, really important. I think I actually put these slides together on the train right here, so I think I've got another slide on that particularly. But those are two things that you really, when you're building a React application, you really want to like think about how it scales, and think about those are basically a separation of concerns between React as a view layer, state management, and side effect encapsulation. So this is like a typical problem. I think I've experienced it before as a JavaScript developer. Some of you guys might have done as well. It's like, what do I install? Like, where do I start? Like, I need React, but then do I need other things? How do I test? Like, where do I start? And actually, it's summarized by this. So like, this might be a typical dev stack. I mean, yeah, it's a little bit verbose because I've put in like TypeScript and Flow. They're kind of comparable. You might need Babel, Prettier, because like formatters are great. They kind of can be better than Inter sometimes. You might want to use Mutable.js. That gives you like persistent mutable structures in JavaScript, which is really, really cool for performance when you're having to scale out your objects and you're making lots of quick changes to those large objects. You can see a performance benefit in that. I actually had to label that one because I had no idea what that was. It's very abstract. That's MobX, so that's a similar idea of state management, I think, to Redux. Webpack, obviously you need that. Everyone needs that, I think. Yeah, Babel, because everyone likes JSX and like you want to use the latest and greatest in JavaScript. Redux Saga, side effect encapsulation, if you've heard it, that's like uses Redux middleware to like dispatch or invoke side effects. So I will just show you something quickly. So the thing I want to summarise on this is that like you need all these things. So ultimately, your idea is to create, ultimately at the end of the day, is to create like a scalable web application that's really performant, separation of concerns, and it's easy to maintain and develop. Now, JavaScript gives you all these things, but actually like trying to put them together in any meaningful way can take hours. Like it can, I've done it before. After kind of a day, I've got something that semi-resembles like a bare bones application, but it's difficult. Wiring these things up adds time and complexity and increased potential error surface as well if you don't wire them up correctly. Like you don't really care as a consumer, not consumer of the application, but as a developer, you don't really need to even care about wiring up these components together. They should all be done for you. If I just do this, so one of the benefits, one of the disadvantages that was touched on in the last talk was the fact that JavaScript is weakly typed. So I just want to like show you this because it's quite funny because I thought about it earlier. So I'm just not actually going to do anything with Google. So if everyone, oh no, that's actually on. Let me go this. So you take this, and then I need to put that in my browser, my console. So you probably kind of inferred through my tweet kind of what that actually renders out as, or what do you think that renders out as a meaningful value? Potentially nothing. It's 20. So that makes absolute sense. So yeah, there we go. Then go back to the presentation. I thought that was quite funny. So there we go. So there's that. I need to click into it. Oh, there we go. So basically, if we were like to take a step back from everything, if we were allowed to take a step back from like writing JavaScript all the time, like trying to write web applications, like what can we take from what we've learned from React and Redux and all these things that like you have to hook up together to make these things? What can you take from that? And if you were able to, had the time to, like what could you actually propose? What could you come up with to actually make this easier for yourself? So what if we never had to write this boilerplate again, keeping our surface area as slim as possible and entirely declarative and feature focused? As I pointed out, you shouldn't have to care about wiring up things, you shouldn't have to care about checking for like types in JavaScript or the lack of types. That's potentially a problem as well. You can have uncaught exceptions from that. You don't want that at all. You don't want that to service to the users at all. You don't have to deal with invoking side effects at all. So this is a really important one. So you want as much as possible, you want your application to be as predictable as possible. That means that side effects, you don't want to be able to invoke them yourself. They're hard to test and they're non-predictable inherently. We're able to get faster feedback than waiting for our JS to run in the browser. Now, this was a point that was touched on like in the previous talk, which is really good, about types in JavaScript. Like you want fast feedback, right? You want to, if you have a typo or there's a bunch of code in error logic or there's an if condition, for example, that doesn't evaluate, and you've accidentally typed in something you shouldn't, then you want to know about that as quickly as possible. You don't want to defer that to compilation in Webpack, and you don't want to have to be able to need to evaluate that in the browser, because at that point it's there. You want that as quickly as possible. And yeah, you can make the guarantee of no runtime exceptions. Like that's insane from a business perspective. Like if you don't have runtime exceptions, or you can guarantee there's none, then that's absolutely brilliant, right? Like your users shouldn't see that at that point at all, like completely. So I'll put a transition on this. Sorry. Yeah. So this is a language called Elm, and it was created by that guy, and he's speaking like next week, I think, at Edinburgh JS, which is really cool. You guys should definitely go along. It was created like for his thesis at university. It's a language and also it has a native framework that allows you to create very, very declarative web apps. And some say it's pretty hipster as a language, but that's not the reason you should use it. So it is a statically typed pure functional language that targets JavaScript. So the lowest common denominator for the browser runtime is JavaScript, right? JavaScript is the only programming language in the browser that you can do anything with. So what happens if a language like Elm was able to compile to JavaScript? Like, you don't have to write JavaScript anymore. It's great. So statically typed, So Matt touched on this earlier. Static typing is when the type of the type of value is not at compile time, basically. So faster feedback, that's really important, and that's why statically typed. So you can, I'll show you some examples in a bit, like the compiler in Elm is like insanely cool. There's really detailed like type inference as well. Really friendly like error message on compile time. So it's literally like having like a buddy who's an expert in Elm sitting next to you and coding away. Well, that can be annoying at the start coming from JavaScript where you don't have to care about like compile errors, but I'll show you why it's so good. There we go. So it's purely functional, and so this kind of builds on the concept of like functional programming. I myself have like come from functional programming because of like things like React. I've traditionally been like a JavaScript developer, but if you were to take that paradigm and extend it out, and within reason take it as far as you can, as pure as you can, excuse the pun. So it has no reusable interface to it. So unlike JavaScript, where some of its standard library allows you to mutate in place, for example, like lets in ES5 or ES6, like let in const, there's no let, it's always a const, like you cannot change that value, it's immutable. So it's more predictable. Code functions by default, so this is the idea that you can start consuming values as separate argument parameters to the point where it's invoked, which is really, really cool. That's an idea of functional programming. No side effects at all. So some of you might be wondering, like, how is this a workable web application if you can't invoke side effects? Well, I'll show you in a sec. And another part of functional programming that Elm adopts is persistent immutable structures. So if you noticed on one of my red slides where JavaScript was like immutable.js, so that gives JavaScript persistent immutable structures, which is really, really cool, because if you've got persistent structures, that basically means that once once you've scheduled an update to that structure, then it still lives on after the new structure is available. That allows you to very performantly, or the library very performantly, to actually structurally share that, which is a massive performance benefit on large structures. This is a native thing in Elm, so it's really, really cool, it's very performant. Stateless functions, so the idea about like JavaScript, you can write, it's a hybrid, it's like OO, but also you can do stuff functionally with it. The fact that you actually can't encapsulate or you can't store state in functions at all, like it's just not possible. But I'll give you a practical example of actually why that's quite good. Targets JavaScript. So as I explained, before I do that, who's used Babel before here? Doesn't matter if you haven't. Cool, so you're already using a compiler. That's really cool. So JavaScript has kind of become a compile target now for multiple languages. So a couple of these, I've just listed some out. CoffeeScript, which is like, I think, is it like a superset of JavaScript, or it compiles to JavaScript? It's just another language. ClojureScript as well, so that's the idea of like using Clojure, but rather than compiling to like the JVM, Java Virtual Machine, it compiles to JavaScript. So you've got that like compile target interoperability, which is really cool. And Elm, obviously, and syntax transformers like Babel. So JavaScript is kind of using Babel, without going into too much detail about it. You've kind of got this this bastardization of JavaScript now. Like some of you might write still like JavaScript that you can only run and is only supported in the browser, but others might have used Babel before, so you can actually transpile to the JavaScript that the browser supports. It's basically taking that idea and like putting it on steroids and basically writing stuff in other languages that just compiles down to JavaScript that you can run in the browser. So this sounds great, but how the heck do I get anything done if I'm not allowed, if I can't have side effects? So the Elm architecture. So as I mentioned when I first introduced Elm, Elm is like a language, but it's also got an inbuilt architecture that allows you to declaratively create web applications. It's really, really simple. This part might seem similar to like Redux, except at this point, this is where we have your middleware, where you dispatch side effects. in this case, in Elm, what you can do is you can actually dispatch commands. Commands in Elm allow you to do things outside the control, outside the scope of the application. So talking with the outside world or doing anything with side effects. Also, I'd point out that you don't care you don't care about the runtime at all. Like that just goes away, and you command Elm to do stuff. So you don't have to take care of like invoking HTTP requests. You just like command Elm to say, I want to invoke this HTTP request with this data, or however you want to do it, and Elm just does it for you. It just manages it all for you. So now we're going to do some coding, I think. So what I've got here is one that I've made earlier. So none of you probably ever seen that at the moment because it's all commented out, but it's a working Elm application basically. It does something cool. Harder. So what I'm going to do is like slowly uncomment this. So and I'll talk through like what it does and why it does it. So first off, this might look familiar to some of you guys who have used like ES6 imports before. Instead of doing an expose default function, you just basically expose it at the top. So module main exposing everything in there, all the functions.
Could you zoom it in a tad? Would you make it zoom it in at all?
Oh yeah, sorry, yeah, absolutely, yeah, absolutely. If I'm going too fast, you can give me a shout. Absolutely fine. Yeah, sorry about that. So we're exposing our module here, which is all this module function definition in this file. We're importing some standard libraries that come standard with Elm. So HTML is really important as well. We'll get onto that in a bit. HTML events, that's a separate namespace in that library. So on click, on submit, everything like that, that's a separate thing. We need to expose HTTP, that allows us to make HTTP requests, it's kind of self-explanatory. Now, an interesting thing about Elm is that as a consequence of interacting with the outside world, for example, get request, that's fine. Elm can handle requesting on a get endpoint, for example, but it's going to return data, right? And it might return JSON, for example. Probably will return JSON, to be honest, if it's a super good API. You need to decode that now, right? Because that JSON structure that's coming back to you might be completely unwieldy. Like it might be based on like multiple requests at endpoint. It might return you different structures of JSON. And that's a point where that's a risk of uncaught exceptions in runtime. You need to handle that. So what you need to do is you need to be able to decode that JSON into Elm values basically to guarantee no runtime exceptions. So we'll get on to that in a bit. Now Elm is a statically typed language and everything is a type here. So yeah, this is what I'm going to be doing. So basically the scope of the application is to click on a button and then return like a random beer from like Brewdog's API. So what I want to do here is I want to create like a type alias. So basically that means I'm able to use that variable beer anywhere else on my application, similar to TypeScript, so like type annotations in line with the functions, or with flow it's above the functions it relates to. So I'm expecting beer to have to be a record. So that looks, very similar to JSON. So name, description, image URL, and those are all strings. So you have to declare types like consistently. But that's really, really cool. I'll show you that. In fact, where's the best place to start? I'm going to start down here. No, I'm not. I'm going to start here. So this part here. So what I'm doing now is I'm actually declaring a new type. So in JavaScript, you have like a number of natives. Like native types like string, array, like object and things like that. But what I want to do is I actually want to create a new type in Elm. If you have a look at this, the type of message here in my application basically correlate to like a Redux action. So like that will be a side effect of that one of those values will be invoked from like an on-click basically. So I'm saying that I would create a new type that could either be find beer or it could be receive beer with that annotation there, and I'll go into more of that in a sec. So it's either one of those values basically. It's what's called like a union type in like functional programming. It's like a tag sum. You're creating new types. It could either be that or either be that but can never be both at the same time. That's really, really cool, and I'll tell you more about it in a sec. So this is also really cool. There we go. Actually, that's a comment, so I'm going to uncomment that, but I will uncomment it for the time being so you can actually read it. So this is like, if some of you might have used like Redux before and like might be like have already adopted patterns for dealing with asynchronous data and like request response cycles and HTTP request response. So for example, when you click on a button, you might have a flag in there which says loaded or loading as true once it's loading, and then you reset that in your reducer or your state store to false when it's been requested. The request has been finished and you've got a response back. Now that's cool, but it's kind of like, shouldn't be the same concern. So in essence, actually, what you should have is actually be its own type. Like, if I explain it like this, so I'm going to do that. So what I'm going to do is specify a new type, and the is called broadcast, and it can either be of 4 things. So this basically mimics what like an HTTP request response might be. So like, first off, when I start an application, I haven't asked the API anything, so it's going to default to not asked. When I start clicking on the button, that's going to invoke the side effect, the HTTP request, and then it's loading. That's the loading type. So the type is changing as I emit it and as I want to do things with it. So then either you could get an HTTP failure, like a non-200, or you get an HTTP success with some data returned. So what I'm trying to do here is I'm representing HTTP request response in like one type that have 4 values, distinct values. And this is also interesting, believe it or not. So I'm creating a new type alias here called model. Now model, again, if you come from Redux, model basically equates to like your root store, like what it would be. So what I'm doing there is actually modeling what that store would be. For the case of what I'm doing, it's only going to have one like field in it, which is going to be result. So if you have a look here as well, the result is of type broadcast, right? So like result could be either of those 4 things at any one time. As I discussed earlier, we need to decode JSON, so we need to decode the JSON response being returned to us from the API, and the way that we do this is use a JSON decoder and Elm. So essentially, what this does is given a JSON string back, then we'll decode it to an Elm type. So what this does, if you have a look, so we're using the type alias that we created earlier, so that's beer, and what we're doing here is each of these declarations is obtaining that field from JSON with that name, basically. And the really cool thing about this, without going into too much detail about it, is that this is we're using this in what's called a type constructor, right? So like each of these values, their order is guaranteed, so each of these values maps to one of these. So name is the first argument, description is the second argument, maps to that, and image URL maps to that one. So it's a really, really easy way of creating like a type instance. So we've done that. I'm going to actually just put this back because otherwise it's not compile. Do that. There we go. Yeah, we've got that. I'm going to start that. I'm actually going to do that one time in. So this is basically our entry point application. So this is basically like what actually instantiates an Elm application. So HTML program is the Elm architecture basically. What that takes is a function that takes an init. We'll go on to init in a second. It takes a view, which is literally just a stateless representation of the UI at any given point in time. An update function, which is similar to like a reducer, I guess. So given one of our messages that we defined higher up, and given a state that I want to return this state, like this immutable state that comes back. Subscriptions, you don't have to worry about that now. I'm basically no opting that. So subscriptions, I'll get onto this in a bit, but subscriptions are a way to communicate outside of into JavaScript, into Elm basically. It's a way of communication between the two. So this is our init function. So if you notice here, so we're starting to get into types now. In fact, it was actually up here. So these annotations, these are type annotations, like delimited by the colon here. So my init function returns a tuple. It's called. So that's something from. That's a part of, like, I guess, like functional programming, like the idea of tuples, which are I think it's two values at a given point in time, similar to like an array. So each of these type annotations actually refer back to other things that we've defined before. Like, so basically what this is saying is my init function will return a model and a command that I spoke about earlier with a message. So as if you remember, a command is like a way of doing things in Elm outside of the scope of Elm. Again, we're using like a type construct here. So if we have a look up, our type alias takes one result, right? It takes one key which is a result. And in the same way we were doing up here with the type constructor, we're doing it there. So basically this is the init function of our application. When we fire it up and we go to that page, that model, that value of result in the model is going to be of not asked, because we haven't done anything with that, with the side effect yet. It's just not asked. We haven't asked anything from the endpoint. And we're not returning, so command.none is a way of saying to Elm, I don't want anything to be commanded at this point. Like, it's just there, like it doesn't matter. So this is what's really interesting now, because this is the update function, which obviously is fed into the HTML program here. So what this is, it takes a message, which is another type, obviously defined up here. Message, it could either be find beer or receive beer. And what we're doing is it returns a new model with a command message. So taking a message with a model, I want to return like a new model, a new representation of the model, and therefore it'll be like a new view representation. So very, very similar to like React or Redux. So what we're doing here is these are similar to like Redux actions. So we fire messages potentially from like our event handlers, so on click, which we'll use in a sec. And we want to fire off the message of find beer, for example. We want to do something with that message. And you'll notice here as well, this is a way of this is similar to like object assign in JavaScript, where basically you want to take this key in the model and return a new model. Very, very similar. So now we're saying that we started the idea of finding the beer. So then the state is it's in a loading state, right? We've invoked, or we've commanded Elm to invoke that side effect. So we're in a loading state. Something else we want to do here at this point is we actually want to kick off we want to say to Elm, go and do this HTTP request, where command comes in. So that's the signature here. So we go up here, get banned beer. Again, type annotation. So it basically returns a command and a message. So basically, it's a very declarative way of saying I want to send a response to a request to this API, and I want to return receive beer. Like on the response back, it's either going to be an error or a success, and I want to return that message, which will then create a response for an update. So here we go. So if we go down to here now. So here we go. So find beer kicks off get bound beer, which is that function there, kicks off or commands the side effect to happen. And here we go. So we've got two messages here that our command will return either an OK result, which is denoted by OK, with an argument that B is like the beer response, or it could be a network error, for example, a non-200, and we have to handle those. Elm instructs us to do that. There's no way that you can't handle an error at all, and you actually can't purposely throw exceptions from Elm. That's impossible. So basically what we're saying here is now we want result, which can take a broadcast. We want now, it's actually an HTTP success with a response back, or it could be an HTTP failure. So notice here how we're changing the type of what result is because of a change in the state. And we'll reflect that in the view in a second. So this is our view. So I'll just uncomment this. There we go. So this is the view. So if you squint, like this might look a little bit like JSX potentially. So a div can take an array of attributes and also like its child nodes. So in this example, I'm always rendering out a div with a button. You'll notice here this is the on clicks, very similar to like JSX syntax. So I want to say on click, I want to dispatch this message to the update. I want to find a beer, and then that's handled in the update in a centralized place. Find some beer. Maybe that's did that. So if you remember, model result can either be not asked, loading, HTTP failure, or HTTP success. Right, so Elm, you have to deal with that within Elm. Like for each of those values, like you have to put something in there, you can't not. So when it's not asked, I'm waiting for your choice. That just runs out a p tag. When it's loading, I'm loading a random beer, and then you are handling HTTP failure and HTTP success as well. So I know I went through that very quickly, but what I'm going to try and do now is like actually just compile it. Oh yeah, and I'm using Elm format as well, which is like it's like pretty, it's a formatter for Elm basically, JavaScript. Let's say make, yeah, that's handy. Sweet. So this is our Elm application. So if you have a look, because the we're not asked yet, I'm waiting for your choice in beer. In fact, I'll just zoom that in so you can see that. So I'm going to click, and then that's going to be loading because there's been a change in the type of what result is. So there we go. Oh, it's loading. Great. And we've got a result back as well, which is like decoded. So that's an HTTP success, and that's handled with the result coming back from the type. So we're basically, we're not dealing, unlike with JavaScript, we're not dealing with like potentially different properties. We're not having to deal with loading flags like true or false or booleans. We're not having to deal with like maybe an empty array in which like a successful response might come back in. It's like a single type, basically, which changes depending on the request response cycle. So that's my little beer app. What I was going to do is just show you the type inference that Elm comes with. What I will do is I will, say for example, I forgot to handle this. So I forgot to handle the loading case. Oh, handy. There we go, and I'll actually just zoom that in, sorry. As well. So the compiler, very, very handy, and it says this case does not have all possibilities because it's aware through type inference that there's a branch of logic that I haven't accommodated for. So it's just telling me, right? So it's really easy to do. So that's my application, which is pretty crap. I knocked it up in like 2 minutes. No, I'm not going to do that. Sorry, where am I going? No. Oh, there we go. So one thing I was going to do is very, very quickly, before I get onto my few other slides, I've literally only got a few left, don't worry. I'm going to put this here. So this is good old Babel, just to show you how Elm is type safe, basically, and the inference that comes from Elm. So I'm just going to zoom this in quite a bit. That's really shit. That doesn't actually work very well. So very quickly, we've got a to full name function, takes a person, which should be an object, and returns person first name, cat name, last name. So spot the issue here. In fact, I'll tell you what the issue is here, just for purpose of time. The issue here is I've got a typo here. So that's gonna have an effect on exceptions. You don't want that to ever come to users. Basically, you want to be aware of that as soon as possible. But Babel, because it's just a syntax transform. It's not really it's not a type compiler. It just compiles it to you anyway. So you're compared to. Come on, learn something. Right, okay, go. So this is a comparable. There you go. So this is just Elm repo online, like anyone can go to it and just type in some stuff and play with it. So I've done the same thing basically. I've mimicked like what that function does, the invocation, and in a very similar way to the branch logic where like nothing added up and the compiler threw an issue at me to let me know. This is the feedback from the compiler. So instead of actually just accepting it and compiling it anyway, it's inferred that the types are different or the types don't add up on compile time, which has meant I'm aware of that issue like at compile time and I don't have to defer that to the runtime evaluation, which is really cool. So you go first name, so you can change that. If I change that? Yeah, so that will compile once I change that. Okay, so we've coded. Here you go. So very quickly, there's like 2 or 3 more slides. Communicating with JavaScript. At some point, you want to communicate with JavaScript. You might have a library somewhere in globals that you want to interact with. So what you might want to do is like push a value out of Elm into JavaScript land. Conversely, you might want to Elm to accept a value from JavaScript. You might want to do something with it and consume it. So the way that you do that is through ports and subscriptions in Elm. So a port allows you to. This is like really shit. Oh, sorry. In JavaScript, in Elm, you can either do ports or subscriptions. That's exposed to global in JavaScript. So Elm.your app name allows you to have access to that. So you can immediately like establish a connection between JavaScript and Elm, which is really cool. So can I use Elm today? Absolutely you can. So what I've started doing at like my 10% time at FanDuel is actually like starting to swap out React components. We have like a Redux application, and I was like, I just want to try out some Elm. So basically what I did was I swapped out one React component and replaced it with an Elm application, like using ports and like subscriptions. Basically what that equated to was the props that that React component took, I just passed that down and transformed that into Elm values, did stuff with it, it rendered out a list of like form fields, submitted that form field, and also pushed that value out of Elm into JavaScript again. So it's completely interoperable with JavaScript in that sense. So what sucks a bit about it? So at the moment it's on like 0.18 as like a version release. It just ignores Semver, like it's a dramatic release, it's not like a minor version, it is a major version, but we're on 0.18. So there's no code splitting at the moment, which is kind of a bit crap. The runtime is quite small. Obviously, when you're compiling an application like I've done, its entire runtime to allow you to do everything. Kind of large. There's no code split at the moment. That's addressed in the next version of Elm. So like Evan, I'm sure will give an update on that like next week, which will be cool. Component state is non-existent. I'll leave it up to you whether to decide that's a good thing or a bad thing. No isomorphism. So unlike with React or JavaScript, you can't render Elm on the server and on the client. It's only there to render out browser-side JavaScript. It only compiles to that. No lazy loading, but that's addressed in 0.19 as well. No tree shaking to like minimise. No tree shaking to minimise like the size of the bundle. So rather than dead code elimination, actually doing it beforehand and evaluating in the AST exactly what your bundle requires. That's not there yet. There's a relatively small community size. Now, like everything compared to JavaScript is like pretty minimal. Like the JS community, like for one reason why like JavaScript is so good is because the community is massive. Elm isn't like that. It's not like a mainstream thing. I kind of fear that like one of its competitors, like Reason ML, which from Facebook, might like supersede Elm just because it's Facebook and everyone likes it. I don't know, but at the moment that could be seen as a disadvantage. The community is really welcoming, really friendly, but it's just not as large as JavaScript. CSS integration, some of you guys might have used like styled components to export like React components with some styles on. That type of like style encapsulation is now in Elm yet. It's quite brittle in the way that it works. You can do type CSS because Elm is typed obviously. Takes a bit of setting up and it's not the best thing in the world. It's kind of difficult. Yeah, that's my slide. 20 out of 20. So that's it. I hope you enjoyed it.
Questions? Do you
So we've got a couple of people who are who I'm hacking around with on Fridays, like trying to achieve the same goal, just like proof of concept. No, like outside of that, no. But like it's actually quite cool, like how I guess like how people are excited about writing that type of stuff. I think like because of the JavaScript fatigue generally, and like having to create doing lots of boilerplate to get stuff working, Elm works very, very simply, and it kind of works out the box, and that kind of excites people, and it pushes functional programming more. So if anything, I feel that like it's just getting people more excited to work about it, which is cool.
Well, it's a fairly obvious question. I mean, if the CSS is a pain in the ass, how the hell are you going to build anything realistic?
Yeah, it's a good question.
CSS is just essential.
Yeah, absolutely. Yeah, yeah. It kind of depends on like what you need. So given like the advantages that Elm has, many of those become apparent when you actually use it. It's kind of a trade-off. So it's like, do I want to sacrifice CSS class names as an implementation detail, like similar to what Star Components give you, or CSS modules, or would I be okay and still happy writing like them, for example, like block element modifier? That's the model. Yeah, it's kind of quite old, but like you either have to use type CSS in Elm to achieve that type of encapsulation, or you have to rely on globals in CSS, which I don't think anyone really likes. So that's one of the disadvantages. As much as I like Elm, it's only fair me to like list the downsides, potential downsides to it.
Yeah, so, I mean, it's really, it's targeting only client-side JS until that CSS integration.
Absolutely.
It's not going to be anything more than that.
Yeah. Yeah, I mean, as I say, I think like CSS, like it's not even just CSS integration that like people are like dissuaded about it. It's like the fact that there's not a massive community around it. It's like kind of seen as like a relatively like hipster language with no actual backing.
And there's lots of things like that.
Yeah.
I actually heard about this 3 years ago in Holland.
Great.
People were talking
Yeah.
about
Yeah.
in Holland.
Yeah. I think you're right. I think if for like more adoption, like if the CSS interface into Elm was better, then that would be like far less of a pain point. I absolutely agree.
I mean, it's part of the reason that React has become
CSS encapsulation stuff. Absolutely. Yeah, absolutely. Yeah, I think that's I think that's to do probably with the community and the fact that like so many people are behind like React, and so many people are creating like incredible like tools for using React and like CSS encapsulation of styles in components. It's probably a byproduct of it just not having as much traction as React or something backed by Facebook. That's to say that it's not like going to change in the future. Like Elm's becoming more popular, and I want to like contribute a few things related to CSS with Elm, but who knows?
Yeah. Is it something they're addressing currently? Do you know?
Chap's coming next week, will he?
Yeah. I mean, he's the author of it, so I hope you should know. Yeah.
Everything I can live with, but no CSS.
Absolutely.
Or a website, client side.
Yeah, absolutely. I mean, that's my experience. That's my experience of using CSS in Elm. Evan might be like, oh, actually, like this is the way of doing it, and I might be completely wrong. So it's just my experience of it. But yeah, it would be interesting to hear what he has to say on the subject.
Maybe ways around it, as long as it's kind of like predictable.
Yeah, and maintainable. Absolutely. Yeah, I agree. Yeah.
One thing, I have a question, but one thing to be clear is that Redux was entirely inspired by the Elm architecture.
Absolutely. Yeah, absolutely. It's a good point. Yeah.
It's like a pet project.
Yeah.
But my question was more around, was Elm the first step into functional programming that you had, or had you had experience?
No. So like pretty much like a lot of people, like I came from like React. I checked out React, and then I was like dispatching or like doing HTTP requests in my components. I was like, that's not very testable. Then I needed a state management system, so I looked at Redux, and then I was like, actually, the idea about keeping your state management or your root store right at the edge of the application, as well as side effects, makes everything very testable. And then I heard about Elm, and I was like, oh wow, this is actually built into the language itself as an architecture. I'll have a look at it and evaluate it.
Like as a type system, the language itself, had you done anything like Haskell or ML or?
No, I haven't. So like Elm is inspired by, I think it's written in Haskell, it's inspired by ML as well. So yeah, no, I haven't. I came directly from JavaScript. Yeah. Yeah.
Interesting. Did you say it doesn't compile into JavaScript, right? It's at runtime it does.
So it's got a compiler, much like when you compile to. It's got a much like Babel and Webpack. Like you compile it. So for example, in CI, when you do production release, you use the Elm compiler. That compiles like a JavaScript bundle that can be used in the runtime, and then it's just like a Webpack bundle basically. It compiles JavaScript that can be run in the browser. So that program, that source code that I was showing you earlier, that just gets compiled to JavaScript.
Not at runtime. It can be.
No, it's absolutely at compile time. Yeah.
So sorry. Go. Debugging then. How do you?
Yeah, it's a really good question. Really good question. So I've only done like 2 projects in Elm. There is a similar thing to like console log basically. Obviously you shouldn't use it in production because it's like a side effect itself, but you can definitely do it and you can debug. One of the things that I didn't touch upon here is because the entire componentry and everything's entirely stateless and functional, you can actually use what's called like a time traveler. So you might have heard that expression through Redux. It basically allows you to debug the entirety of your application lifetime. So example, if I was to click on many buttons and things happen on the page in an application, you can actually debug that and actually use like a scrubber, I guess, in HTML to literally like reverse time, to go back in time, because everything's stateless and predictable. So that's a really good way of debugging events and like issues that have happened. But ultimately, as I said, like there's no runtime exceptions at all in Elm. If that happens, then that's a bug in the compiler itself. Like that should never ever happen. So the cases where you actually need to debug stuff in production potentially is minimal, I say.
Does that reduce testing too?
Yeah, absolutely. I think like the combination of like the application, like the architecture being so like declarative as well as like having a static type system, it's actually quite difficult to like TDD in that sense, because like you fall at the first hurdle, like you haven't defined the types correctly, you need to create type annotations, and like literally at the last second you actually have a test that's actually failing for the reason you want it to. So in that sense, I wouldn't write tests for any of the application I've done, because at the end of the day I write unit tests to describe the intent of what something has done, whereas actually there it's incredibly clear because it's so declarative what I want it to do. So I think, yeah, to answer your question, like the number of tests is less potentially. Yeah.
Interesting. Okay, that's great. Thanks, James. That's great. Thank you everyone for coming. I'd like to thank Deloitte again for the wonderful space, lovely view. It's a nice day. We always need speakers for our next events. We are taking a 2-month break. We had planned a very special speaker, but that'll be for our next one. We'll probably be in person, so you can call it in. Anything else you want to mention? Again, Code Your Future, anyone interested, come speak to us.
We have the tech meetup on
Wednesday.
Yeah. So hope to see some of you. We'll talk more about Code Your Future. Yeah.
And then Node.js on
Tuesday.
That's going to be amazing.
Fantastic. Thank you all for coming. That's great. Lovely turnout. See you guys soon.
Cheers.
Cheers.